Hello everyone, I am Dr. Shailendra Kumar, Assistant Professor, Department of Electrical Engineering, IIT Bhilai. Welcome to the class of EV charging system configuration, operation and control. Under this lecture, today we will see renewable energy integration and control of EV charging system. So, under this topic, we will study about introduction, why the development of renewable energy based charging infrastructure is important, where we will see various wind and solar based resources can be integrated with the charging station, so that the burden on the electricity grid can be minimized. After this, we shall proceed with classifications. Suppose if we have solar based charging station, so how we can classify this solar based charging station. After this, we will see simulated and experimental results. So, we have chosen one topology and we will go through the control, what are the results which we have obtained from this particular topology. Finally, we will see the summary of this lecture. We are proceeding with introduction, and if we see the conventional charging system, so various battery packs of electric vehicles, they are connected to the grid via AC, DC and DC-DC units. So, basically if you are talking about level 1, level 2 charging or slow charging we can say. So, we have on-board charger, these on-board charger are with the electric vehicles, and these units like on-board charger, they include rectifier along with the DC-DC converter. So, responsibility of AC-DC converter, it will convert this AC supply into DC, and the voltage and current at the DC bus and the battery current are regulated using DC-DC converter. Till now in India, we have developed grid to vehicle technology, where these are the unidirectional charger. So, most of the on-board charger, they are unidirectional in nature. So, we can draw the power from the electricity grid and we can charge our vehicle. So, this battery includes 2 stages and it also integrated with power factor correction unit, so that the voltage and current at the supply side, AC supply side, are in phase and power factor can be maintained unity. Now, so we have seen the conventional charging station, where we have not integrated any renewable energy sources. As soon as the number of electric vehicles are increasing, we require more power. In that case, the burden on the electricity grid, the power consumed by the electrical vehicle will be increased, and the power drawn from the grid will also be increased. In that case, the power which has been drawn may be I mean we have very huge demand. In that case, burden will be increased and we need to think about some alternative to decrease this burden. So, that is why the integration of these renewable sources is very important, as we need to fulfill the load demand, or we need to match the peak load demand, and that is why not only integration of renewable energy is important, we have to also adopt vehicle to grid technology. Under vehicle to grid technologies, the number of vehicles can be connected in a pool, and this pool is connected through the aggregator, and this aggregator is communicating with the grid supplier, power supplier, as well as the customer or the electric vehicles which we have for discharging purpose. And this aggregator will establish the communication between these two units, and we can assume up if like 200 or 300 vehicles are integrated in a pool or in a particular power flow, or we can say power source. So, it can act as a power plant which can supply, which can match the load demand during peak hours, as well as these vehicles can be charged as a G2V mode whenever there is less load demand. So, these both technology, integration of renewable energy as well as the adoption of vehicle to grid technologies are important. So, why renewables? Because the availability of these solar and wind is almost everywhere. Shrinking the natural resources, coal and other fossil fuel based resources are shrinking day by day. Increasing number of EVs and the limited power generation capability of the conventional energy based power plant. Therefore, we need to adopt these two technologies. Limited power transfer capability of transmission lines, one of the aspect. If we are going for integration of renewable energy sources, we have to change the power infrastructure, because the power transfer will be both ways. We can, if there is less number of EV at the charging station, we can inject renewable power. If generation is more than the load demand, we can inject the extra power to the electricity grid. Whenever the renewable is down, generation is down, we can take power from the electricity grid to fulfill the load demand or to achieve the load demand. Solar based generation is quite mature technologies. It is renewable and clean energy, suitable for installation in tough terrain. True. So, why the development is important? Suitable for local installation over the parking lot, roof, bus station, petrol, gas pumps. So, we need some area where we can install these solar panels and we can get the electricity. Other advantage, reduction in carbon footprint. Utilizing renewable energy sources such as solar and wind for EV charging reduces greenhouse gas emissions, as our atmospheric temperature due to these greenhouse gases is increasing day by day. So, it is also contributing to reduce the carbon footprint, so that the atmospheric temperature can also be controlled. Grid support and stability. Distributed generation can help stabilize the grid by providing additional power and reducing the peak load demand. They can also contribute whenever there is peak load demand, we can take power from these resources, and they can also maintain, they are helping actually for maintaining the grid voltage and frequency. So, we have developed in our laboratory, we have developed one charging station So, we will see what was the motivation and objective to develop this charging station. So, the charging station which we have developed, it is supported with the synchronization. So, whenever we have renewable based charging station, so it is categorized into two parts. One is standalone charging station, another one is grid connected charging station. In case of standalone, we need one converter which could be control in voltage control mode, where whenever after converging this DC into AC, at the point of common coupling where various loads are connected, we need to maintain voltage and frequency. However, in case of grid connected charging station, the voltage source converter which is utilized for DC to AC conversion unit, it is controlled in current control mode. So, in that case we are generating the reference current, and these reference current are compared with the sensed grid currents to control the power which is injected to the grid or the power which is drawn from the grid. Therefore, in case of grid connected charging station, we need to have well established synchronization between converter and with the grid. So, there is some standard like IEEE 1547, it says the parameter voltage, frequency and phase angle between load voltage and grid voltage must be maintained at a certain limit. Like grid voltage, the difference between load voltage and grid voltage must be less than, it must be in between 0.88 to 1.1 per unit, as well as the frequency must be within the limit also. Like in various cases people are considering 49.9 as well as the upper limit they are considering as a 50.2. So, under this limit we have to maintain this frequency. The another one is angle between load voltage and grid voltage. So, angle, the difference between the angle difference between the voltage angle and this grid voltage must be less than 3 degree. It must not be greater than 3 degree as per the standard. So, if we are able to maintain these 3 parameters, we are allowed to synchronize our charging station with the grid. Therefore, people are using various synchronization scheme, islanding scheme to synchronize and island our system charging station from the grid, or we synchronize our charging station to the grid. Whenever there is outage from the grid, so we have to disconnect our charging station. Whenever there is connection to the grid, we need to, whenever there is islanding is happening, some fault is occurring toward the grid side. So, we have to disconnect our system so that this charging station can be protected during the fault. So, the system which we have developed, it is automatically synchronized, it can connect and disconnect from the to the grid without disturbing the EV charging and household supply. So, one important thing during mod transfer, and this converter is utilized 24 hour. It is not like that whenever grid is not there, then we have to shut down our charging station, because we have installed one battery bank and one renewable energy source. So, whenever there is outage of the grid, we can take power from the battery bank. If SOC of the battery is maintained up to certain limit. So, what are the disadvantage of a conventional charging station? Like for protection region, conventional charging stations are mandatory to shut down automatically at loss of grid. However, the presented charging station is developed to establish continuous power supply to the vehicle as well as to the consumer load. So, we have operated this PV based charging station in various mode like vehicle to home. Whenever it is operating in standalone, we have operated in vehicle to grid mode, grid to vehicle mode, and various operations are achieved which can increase the utilization factor of the charging station, and it decreases the payback periods of power converter units. So, during vehicle to grid, the active reactive power support to the grid is also provided, and we have other advantages of this renewable grid integrated charging station. We are able to reduce the distribution losses, it has bidirectional power flow capabilities and static switches we have used to improve the reliability of the charging station. So, as soon as there is high demand of vehicles which has increased the higher fuel prices, and other side if we are finding out the continuously use of this renewable energy sources, the cost of these modules are decreased day by day, and it is still decreasing day by day, which has paved way for the fast development of renewable based charging stations, and we can use these EVs as a future mode of transport. So, we have indirect cost reduction. We will also discuss the control of EV charging stations, where in control we have used this PV feed forward loop, and using this PV forward loop, grid must know how much power it is coming from PV, so that the dynamic response oscillations in the grid currents can also reduced. The charger is also controlled to operate as an active power filter, as we have discussed. This unit is also integrated with the power factor correction unit. So, here this AC to DC or DC to AC unit, it is acting as a active power filter, so that the power factor corrections and total harmonic distortion of the grid current can be limited within 5%, and there is one standard again for limitation of harmonic, that is known as IEEE 519. So, it says if you are injecting power or you are drawing power, you are not allowed to inject harmonic more than 5%. So, we have to follow these standards. Now, we can see the advantage of integrating solar energy with the charging station. So, if you are taking 2.5 kilowatt system, suppose a roof of a house is available for installation of 2.5 kilowatt system, where we have installed. So, this 2.5 kilowatt system will produce an estimated 3000 kilowatt hour of energy, annually, and it can be noted down, it is sufficient for 1000 miles per month. So, this is the advantage of installation of this rooftop PV at household. So, here we have classification of solar PV based charging station. We have classified as per number of supply phases initially, So, it is categorized into single phase and 3 phase. In single phase, mostly level 1 charging is done. We have onboard charger, we can plug in and my vehicle get charged in 6 to 7 hours. It is a similar example of 3-wheeler rickshaw, where people are running these 3-wheeler rickshaw in the daytime and night time they put these rickshaw in the single phase socket, so that the battery SOCs state of charge and these battery get fully charged over the period of time. So, single phase charging station, further single phase as well as 3 phase charging station, both are classified depending on the number of stages. So, we have 2 stages, single stage, 2 stage. Similarly, the 3 phase charging station, it is classified in 2 ways, 3 phase 3 wire and 3 phase 4 wire. Because sometimes we realize there is load unbalancing, some of the phases people have put extra load. So, there is unbalanced supply which we are getting from the load side. So, neutral current, in that case the magnitude of neutral current will be high and we need to mitigate this neutral current. So, this 3 phase 4 wire charging station is very famous and it can mitigate the problem of neutral current. Otherwise, we have put the neutral conductor and I square R losses will be significant. To reduce these I square R losses, we have to minimize or mitigate the neutral current. So, this way this 3 phase 4 wire topology is very popular. However, these topologies are further classified as a single stage and 2 stage. In case of single stage, we do not have any kind of converter which is used for MPPT purpose. So, same converter which is utilized for DC to AC conversion during renewable integration, it achieves the MPPT, it performs the function of MPPT as well as it converts the power from DC to AC to fulfill the EV demand, where these at the point of common coupling various onboard and offboard chargers are connected. And then further these charging stations are classified as a EV battery without control, with control and bidirectional. Further they can also be classified depending on the isolated and non-isolated DC-DC converter. So, there are various ways to classify these charging station. Now, if we see the first topology, here we have 3 phase grid integrated charging station. If we go from left to right, we have one PV array and one boost converter unit is utilized. So, it is a 2 stage charging station, where the first stage is DC-DC conversion. So, here boost converter has only 1 degree of freedom and it is converting, regulating the MPPT point, and after getting power at the DC bus CDC, the power is converted into AC by this 3-leg voltage source converter, and this converter is operated in current control as well as in voltage control, depending on the availability of the grid. If there is any fault, so it will operate in voltage control, and the transition of controls will be taken care by the synchronization and islanding control. And further we have certain ripple filter, then a nonlinear load is connected at the point of common coupling. Some onboard chargers are considered over here as a nonlinear load. So, in grid connected mode, charger allows the EV owner to sell the EV energy to the grid for revenue generation in vehicle to grid mode. During the outage of grid and PV array generation, the charger utilizes the EV to supply the household load and vehicle to home mode. So, these two operations are achieved. Apart from these two operations, the injection of power to the utility grid is also achieved whenever we realize there is less EV load demand. So, this VSC, as I told you, the payback period of voltage source converter is increased here, as we have reduces the losses, and in normal PV system, if you see, this inverter is unutilized by 2/3 of the day. By taking various operation, not only operating this converter in as a active filter, we have also operated this converter in voltage control mode whenever there is no grid. So, this power converter is fully utilized, and this will indirectly reduce the cost of operation. Here, if you see, in this topology we have connected one EV battery. However, there are n number of EVs which could be interfaced with the grid, with the renewables. So, you can see at the right side one battery bank we have connected, it is working as a storage for the charging station, and other side we have various electric vehicles. We may have Tata based electric vehicles, we may have Mahindra, we may have Tesla or some other vehicles. And the important thing is, they may have different voltage ratings also. So, using these voltage ratio, we can integrate with the isolated and non-isolated converters. Other side, the PV array is also integrated with the boost converter, so that the MPPT point of renewable energy source or solar generation can be achieved. Another topology, we may have wind energy based charging stations, and in case of wind energy based charging station, we have integrated solar energy and wind energy at the DC bus, and two number of vehicles which are integrated at the DC bus as a fast which require fast charging, and centralized converter is utilized here as a DC to AC conversion or AC to DC conversion unit. At the point of common coupling, we may have various onboard outboard chargers, AC chargers which are connected, and then we can have AC grid. So, here we have a generator which is utilized for this wind energy conversion system, that is synchronous reluctance generator. There is no winding as well as there is no magnet at the rotor circuit, which may improve the overall improve the efficiency of wind energy conversion system, as I square R losses are very less, and it is integrated with the 3-phase converter, and this AC power is converted into DC, and then this DC power is integrated at the DC bus, which can further utilized for charging of electric vehicles and power injection to the grid. So, in case of wind based power plant, wind based charging stations, we have utilized here synchronous reluctance generator, and in case of wind based charging station, we have also improved the power quality, and it is achieved by using adaptive control. Various operations are achieved, like charging to discharging, grid to vehicle and vehicle to grid condition under variable wind speed. Wind is varying from 4 meter per second to 12 meter per second, and under solar insolations variations. So, we have various parameters which are involved in the charging station. So, here we have put a table so that the various parameters using various formulas are designed. We have one estimated value and the final selected value for various component like VDC, CDC, what is the power rating, and then other the IGBT voltage and switch current. Now, we go to the control algorithm for charging station. One topology we have utilized for this. So, in that topology there are 4 basic control which are required. First one is EV battery control. So, one bidirectional converter is utilized for this purpose, and this bidirectional converter is controlled using cascaded PI. We have voltage source converter, it is controlled in voltage control and current control mode. We have STS also, which take care of this mode shifting control, and then finally boost converter control. So, current control and voltage control is achieved here. So, first graph we can see first part where the current control algorithm is utilized and it is shown as a grid tied mode. However, in other part we have islanded control. So, we sense the voltages and we generated some reference load voltages, and these reference VSC or load voltages load currents, they are compared with the sensed VSC or sensed load currents, and then further we have generated the reference. Very important thing, switching of these control from voltage control to current control and current control to voltage control will be decided by static transfer switches, which will provide 1 or 0 signal for switching from current control to voltage control. Here we have voltage phase frequency control, where we have generated the reference voltages as the point of common coupling voltage we have to maintain in case of a standalone mode. And this is the cascaded PI control, where the voltage controller and current controller, they are PI controllers, and outer PI controller it maintains the VDC, and inner current controller it regulates the battery current. So, control of multi-spot EV we can because here the DC link voltage is regulated using a battery bank. However, we require charging for each EVs. So, what we have to do? We have to sense the SOC of each EV through communication and other some software, and these status of SOC is given as a command to we have used a MATLAB software. However, some processors are there. So, a percentage of SOC can be given to the processor and they will generate one reference EV current. This reference EV current is compared with the sensed EV current, and then we can apply a PI controller which regulates the duty cycle, and this duty cycle is compared with the triangular wave to generate the switching signal for these bidirectional converter. So, this way we can select the mode for each EV, and here we have synchronization control, where we need to maintain the voltage, frequency and angle. So, these are the few comparison why we are not going for a conventional phase lock loop, why we are going for advanced enhanced phase lock loop, and then we can go with the energy management in a smart charging station. So, depending on the parameter, grid parameter, depending on the SOC parameters, depending on the availability of grid, depending on the renewable energy sources, each units they are communicating with each other, and then this control will take the decision. So, in a smart charging station the energy flow is very important, and we have to integrate a energy management scheme. So, here we can see some results under outage condition and then simulated under recovery of utility. So, as soon as at certain time instant we achieved, like there is a grid appears. So, under this condition grid voltage and currents are there, and accordingly we can switch the battery. Suppose in this case of standalone the charging was required. So, battery current was negative. As soon as grid is there, so we can considering SOC of the battery is maintained and the battery is switched from charging to the floating mode. And similarly, few dynamic results under load unbalancing, where grid currents are maintained sinusoidal under during one phase, when one phase is disconnected from the supply. Here we have the total harmonic distortion, which is within the limit of IEEE 519 and it is 4.51. However, load current TSD we can see that is 26.91, and these are the results under variation of solar insolation. And then this topology is experimentally verified. So, we have certain components which are utilized to develop this charging station. So, at the right side you could find out there are 4 batteries which are integrated in the charging station. They have different voltages and these batteries are integrated via bidirectional converters. We have bidirectional converter here, a solar simulator is also selected for as a PV rooftop PV array, and the power injection is taken care by this renewable power which is supplied by the PV source. It is supplied by this PV simulator here, and then as a control unit we have DSpace controller over here. So, this is this picture is shown for MPPT performance in steady state under 1000 watt per meter square and 500 watt per meter square. Similarly, we have some results drawn from the experimental prototype, and these results are similarly follow the simulated results which we have shown earlier under grid disturbances, and the total harmonic distortion from the grid side, grid parameter like grid current TSD, grid voltage TSD, both are maintained within the IEEE 519. And in the last figure it is shown the injected power to the grid. We have also performed dynamic response in experimental prototype under change in insulation from 500 watt per meter square to 1000 watt per meter square. And similarly, under outage of PV array, if both the sources are not there, so battery bank will be initiated and it will fulfill the demand of power. So, finally, conclusion, in this lecture we have seen the charging renewable based charging station, and these charging station have the capability to operate in grid connected as well as in standalone mode. We have also seen why this renewable based charging stations are important. I hope this lecture will be beneficial for you. These are few references which can be followed to get more idea about renewable based charging station. Thank you very much.